Okay, let's do a review of trig. You don't need to take notes on this. You can just pay attention. So let me draw a right triangle. Beautiful right triangle. And I will call that angle theta. Now I could call the other angle theta if I wanted. You're not allowed to call the right angle theta. It causes problems. I'll show you why in a second. So if that is theta, what are the names of the sides of this triangle? So the opposite side is, oh, which one is the opposite side? The one on the left. Okay. So this is opposite. Okay. Adjacent is the bottom one. And the last side is called the hypotenuse. Do you guys know what hypotenuse means in Greek? It's an occupied toilet on an airplane. You guys are quicker than my other classes. It's an occupied toilet on an airplane. Chase still doesn't get it. Oh, it just wasn't funny. I see. Are you telling me I shouldn't quit my day job? Is that what you're saying? Uh-oh, Hannah's got the giggles. Okay. Well, what happens if I move theta to the other base angle? If I move theta up here. Right, the opposite and adjacent switch sides. The hypotenuse stays the same. What happens if I move theta to the right angle? Well, now opposite is the hypotenuse, and now I have two adjacents, which is a problem. So you're not allowed to do that. So if we go back to the original, you just got it? For the sake of your sanity, I won't say your name on the video, so those watching won't know that it was Brooklyn that didn't get... Sorry, I ruined it. Okay, well, let's put some numbers on this particular triangle. The old 3, 4, 5. So 4 centimeters, 5 centimeters, and 3 centimeters. And when we have a triangle that's that big, the angle, I think I remember what it is, but let me double check. Yeah. So this angle is about 53.1 degrees. Okay? Now, there's a really strange thing that happens in right triangles, and that is if we start to compare particular lengths, comparing one length to another. For instance, if I wanted to compare the opposite side to the length of the hypotenuse, how do you compare those two lengths? How do you compare lengths? Measure them, and then if I wanted to know how long is the opposite side in relation to the length of the hypotenuse, you just divide them. So 4 divide 5, which is 0.8. So what does 0.8 mean in terms of the opposite and hypotenuse? Or 80%. So the opposite is 80% as long as the hypotenuse. Well, if I were to compare that the other way, what do you think it would be? Don't calculate it. If one is 80% as long as the other, if I were to compare the long one to the short one, what would it be? 120%. Try it. What is 5 over 4? 1.25. Wait a minute, that doesn't make any sense. Why is one 80% of the other, meaning it's 20% shorter, and the other one is 25% longer? Can you explain yourself? You. So I could say the opposite is 20% shorter than the hypotenuse, but the hypotenuse is 25% longer than the opposite. Go ahead. Josh? Right. It's in comparison to the one you began with. The opposite is shorter than the hypotenuse, right? So 20% of the hypotenuse is exactly the same thing as 25% of the opposite. So 5 times 0.2 is equal to 4 times 0.25. That's why they don't match up. Because if you're comparing opposite to hypotenuse, your comparison is on a longer length. If you compare hypotenuse to opposite, your comparison is in terms of a shorter length. So 20% of 5 is the same as 25% of 4. They're both 1. Okay. Well, what happens if I take this exact triangle and I double it? So now I have 8, 10, and 6. And here is my 53.1 degree angle. Oh, I got it. Sorry, I got it. Ah! I labeled the wrong side. 53.1. Okay, the triangle is similar, same shape. Now it's twice as big, even though it looks smaller. What is the ratio of the opposite to the hypotenuse? It's still, well, it's 8 over 10, which is 0.8. Why did the percentage not change? It's similar, meaning it has a common ratio. So similar triangles have common ratio in side lengths. Well, because of that, we have named this particular ratio sine. So we say that the sine of theta is defined by the opposite side length divided by the hypotenuse side length. And if theta happens to be 53.1, that ratio is 80%. Everybody remember that? So all sine does is tell us, in a right triangle, how long is the opposite side in comparison to the length of the hypotenuse. That's all it is. And that decimal is between -1 and 1. It can't get bigger than 100%. And it can't get smaller than -100%. And we see that in the graph. The graph of sine looks like this from 1 to -1. Because it can't get bigger than 100%. There's no way for the opposite side to be longer than the hypotenuse. Okay, well, what if I don't know the angle? What if I told you I have a right triangle? In that right triangle, the opposite over the hypotenuse is 80%. Can you tell me what the angle is? Not secant. The inverse. So on your calculator, I want you to type in the sine of 53.1. And it's actually 53.13, but whatever. 80%. Right? What if I told you 80%? How would you calculate the angle? Inverse sine of 0.8 is 53.13. Yes. Good. How many of you had a calculator that didn't work? You need to change from radians to degrees. So If you had something that didn't work, you're probably in radians. Push mode and go down to degree. Okay? All right, so if I have three sides of a triangle, how many ratios can I create? We just created one, opposite divided by hypotenuse. What other ones do we know? Adjacent over hypotenuse, what's its name? Cosine. What else? Tangent is opposite over adjacent. Are there any others? Well, inverse is different. So we have sine of theta, cosine of theta, tangent of theta. And that's O over H, A over H, and O over A. What is the reciprocal of sine? So instead of doing opposite to hypotenuse, we do hypotenuse to opposite. That is the cosecant of theta, which is H over O. That you might want to write down. It might even be a good idea to program that in your calculator. So not the inverse, but the reciprocal of cosine is what's its name? The secant of theta is H over A, and the reciprocal of tangent, cotangent of theta, which is A over O. So if I wanted to know what the secant of 20 degrees is, how would I find that? Well, there is no secant button on your calculator. Not inverse, reciprocal. So here's one way to do it. It's the reciprocal of cosine. 1 divide the cosine of 20. Okay? Here's another thing you can do, and I want to point this out so you don't make mistakes in the future. If I just did the cosine of 20, so 94%. The cosine, when the angle is 20 degrees, the adjacent side is 94% as long as the hypotenuse. If you push the reciprocate button, which is just raised to the -1, and hit enter, that is the secant of 20, 106%. But don't get these two things confused. Cosine of 20 to the -1 is not the same as the cosine -1 of 20. This is the secant. Wow. I'm talented. What does this mean? If your ratio is 2000%, what is the angle? Well, if I tried that, second inverse cosine of 20, I'm going to get error. Can cosine equal 2000%? No, it can only go up to 100%. You can't get bigger than 1. Okay? So let's go back to this triangle with a 51-degree angle. Maybe I'll just start over. So 4, 3, 5. This is 53.1. So the sine of 53.1 equals 0.8. If I make that angle a little bit bigger, is this ratio going to go up or down? Well, if I make an angle bigger, what effect does that have on the opposite side? So if this angle gets bigger, what happens to this side? Gets bigger, and the hypotenuse isn't going to change. Okay? So by making this angle bigger, it's going to slide like that. And then this side will lengthen. So we would expect the sine of 54 to be bigger or smaller than 0.8. A little bit bigger. What about the cosine? If that angle gets bigger and the hypotenuse doesn't change length, then it's got this angle has to open up further. This side gets bigger. What happens to the bottom side? So the cosine of 53.1 is 60%. If we drop down to 50, or if we went up to 54, then we would expect it to go down 58%. That make sense? Okay. Well, let's compare the sine of 54 to the cosecant of 54. So the sine of 53 is 0.8. If we go from 53 to 54, would we expect the cosecant to get bigger or smaller? So if the hypotenuse stays the same and the opposite side gets longer, what's going to happen to the cosecant? So cosecant is h over O. If O gets bigger and h stays the same, then the cosecant is going to get smaller. Let's try it. So the sine of 53, reciprocate it, 1.25, we already knew that. Sine of 54, reciprocate that, and it went down. We went from 125 to 123. Okay, is that a good reminder for all of the ins and outs of just regular right triangle trig? The first page of this worksheet should be really easy. So number 1, it asks, what is the secant of theta? Remind me again what the definition of secant is. H over A. So if this is theta, what is the value of H over A? 17/15. Is everybody okay with that? All right, we need to do just a little bit of review. What if I had the square root of 12 over 2? Can I simplify that further? Well, can we change the square root of 12? We can factor it and see if it has any pairs. Right? So 12, what goes into 12? 6 and 2, 3 and 2. Can I pull anything out? I can pull out the 2's. So I have 2 root 3 over 2. And the 2's cancel. So that's one thing you need to remember. The other thing is this. What if I had 4 over the square root of, let's do 18. What's wrong with that one? Anybody remember? You're not allowed to leave square roots in the denominator. Okay? So we need to change that. So I'm going to multiply by something. But what is the only number I can multiply by and not change anything? 1. So I need to multiply this by 1. And the one I'm going to pick is the denominator over itself. So root 18. What is the square root of 18 times the square root of 18? 18, right? Because it's the square root of 18 squared. So I get 18 in the denominator. Well, the top is 4 root 18. Does 18 factor? 3 and 6, 2 and 3. Can I pull anything out? Pull out the 3's. So 3 root 2 times 4. So this is 12 root 2 over 18. Do 12 and 18 have any common factors? 6. So 2 root 2 over 3. So you will have to do those on these problems. Okay. All right. So that takes care of the first page, most of the second page, or part of the second page. How would I do this? The cosine of 10. It's asking what is the ratio, what is the percentage of the cosine when the angle is 10 degrees? Well, you could draw a triangle, but that's a waste of time. Just plug it in your calculator. Cosine of 10, and as long as you're in degrees, it will give you the ratio. But it's a little bit harder to do the cosecant. How do you do the cosecant of 21? 1 divide the cosine of 21. Okay? Oh, sorry. I said cosine. I meant sine. Great minds think alike. Okay. What if I told you that the sine of theta equaled 1/2? So those of you who are trying to work on the worksheet and get ahead, you probably want to pay attention to this. Hi. Oh, we were waiting for you. It's okay. So if I told you that the sine of theta is 1/2, what does the cotangent of theta equal? Whoa. How would you do that? It's actually really easy. So we draw a triangle. We label theta. Okay? Opposite side is 1. Hypotenuse is 2. How do we find the third side? Well, 1 squared plus a squared equals 2 squared. So 1 plus a squared equals 4. Subtract a squared equals 3. Everybody follow me so far? Square root. A equals the square root of 3. Maybe you already knew that. And cotangent is defined by a over O. So it's just root 3 over 1. And I'm done. Okay, let's do another one. Cosine of 4 sevenths. Sorry. Cosine of theta equals 4 sevenths. What is the cosecant of theta? Well, draw the right triangle. Label theta. What sides do I know? Adjacent is 4. Hypotenuse is 7. So 7 squared minus 4 squared. 49 minus 16 is 33. So this is the square root of 33. So the cosecant is defined by h over O. So 7 over root 33. I can't leave it in that form. So I times by root 33 over root 33. This one ends up being a lot easier. 7 root 33 over 33. And 33 is 3 times 11. Both of those are prime. So there's no way to simplify that. Okay, let's do the secant of theta equals 7/10. What does the cosine of theta equal? Go ahead and do that one. If you're writing things down, you're not thinking hard enough. Why is it 10/7? Because they're reciprocals of each other. You could draw the triangle and figure it out, but in this case, I know that those are already reciprocals, so it's just 10/7. And then there are two questions at the bottom of that second page that I want you to also answer. Any questions? Did I answer the question you had at the beginning? Okay. Wait, you didn't have a question, you were just asking? I don't understand.